Hi guys, let's do this problem. Guys, let me read the question first. The viscosity eta of a liquid is given by eta, which is equals to K R raised to 4 over VL, where K is a constant. Use partial differentiation to determine approximate percentage change in eta. If R increases by 1%, V increases by 3% and L decreases by 2%. So guys, I have written those details down here. We are told R increases by 1%. Every time guys we say 1%, we mean 1% of R, that is of the original. For dV is 3% of original V, and for dL is 2% decrease. This represents a decrease, guys, of the L. Now guys, we come and write our equations here. Before we write the equations, let me give you the equation that we are going to use, guys, for this. It's going to be d eta, that is the change in eta, or the increase or decrease, is given by that. This is supposed to be given by, you do partial differentiation of eta with respect first to r, and then you multiply here by dr, like that, plus you come to partial derivative of v, of not of v but of eta with respect to v, multiply by dv, plus partial derivative of eta with respect to L, then you multiply by dL. So guys, this is the equation we are going to use in our calculation. And so guys, the first thing we are going to look for is the partial derivative of eta with respect to R from this equation. So we are going to write, that is partial derivative of eta, or with respect to dr, with respect to r. This one, guys, we are going to get K over VL. We consider K and VL as constant at this time. Then when you differentiate R, you get 4R cubed. Then we go to this, the next one, partial derivative of eta with respect to V. Guys, this one you are going to have, you first of all write the constants. Now all others are constant except V. So I write here L. V, guys, we can put the V here with -1, V raised to -1. And the derivative of V raised to -1 is minus V raised to -2, of which, guys, we can now put V here as squared, like that. Guys, we now come to this derivative, that is derivative of eta with respect to L. So this one gives us from here, that is the equation we are using. So this one we shall get K R raised to 4 all over the V, and that now we come and put L here raised to -1. So finally we shall get this as negative, and then L here we shall put it as L squared, because remember it was here as L -2. So by the law of indices, if we put here, it here shall be squared like that. So guys, we continue. Now we come and now apply the equation, guys, there. That is our equation now. So we write d eta, that is the change in viscosity, will be given by, we start with this, which now is going to be written as K 4R cubed all over VL now multiply by the dr. The dr is 0.01 there, 0.01 r. So 0.01 r like that. We go to the next one, which is this. This is now going to be negative. And then we write k r raised to 4 all over lv squared multiplied by 0.03v. 0.03v like that. That is for that. And then we now go for the last one. This one now is going to be minus again. We write this k r raised to 4 all over VL squared. Now we multiply by the DL, which is negative. So this is going to be negative once again, 0.02 L like that. Guys, from there we come and now we can use our equation here, which is eta equals to K R raised to 4 all over VL. We come and factor out that from all this. And this is how we do it, guys, so that first of all, before we factor out, we have to modify each one of these to have this. So we shall have, this is now going to be equal to the d eta, change in eta. Now we modify this one to look like this. So this one will be equal to k r raised to 4. This is the r we are going to multiply with that one. So we can get r raised to 4. But here, guys, we have v over l down there. So therefore, here, guys, we are going to be left with 0.01 like that. Minus, we come here the same way, k r raised to 4 all over v. Guys, we also have another v here. We can cancel that v. We cancel one of the v. So we are left with lv. It's actually lv now. Because, guys, we should have written L first, but now it's okay. So this one is 0.03 like that. Minus, finally, guys, we are going to have a plus because this and that is plus. We have k r raised to 4 all over. Now v can cancel this L and that and one of the L here. So we are left with like that. So here it's going to be 0.02. That's what we are going to be left with. So, guys, as we continue, we also note that we had a 4 here. And so this 4 should be multiplied by 0.01. So, guys, we come and multiply that, we get 0.04 there. So I make that correction because here we had a 4. So we have to make sure that this 4 we put it there. And so, guys, finally we shall have d eta equals to, we can now factor out k r raised to 4 all over VL. Then we have 0.04 minus 0.03 plus 0.02 like that. So, guys, we can say now d eta or viscosity, this is now going to give us, this is now viscosity, and then we can add this. If we add this, guys, we're going to have 0.04 plus 0.02 gives us 0.06 minus 0.03. This one we shall get as 0.03. And so, guys, now looking for percentage change. It shall be change 0.03 eta all over the original This is the change over the original multiplied by 100. So this is now going to give us 3%. So our change, guys, for the viscosity is 3%. That is in terms of percentage. And so, guys, thank you for listening to me. Bye bye.